Welcome to springlib.
The upper right-hand corner of a piece of paper 12 inches by 8 inches, as in the figure, is folded over to the bottom edge. How would you fold it so as to minimize the length of the fold? In other words, how would you choose X to minimize Y? And this is the statement we are going to stick with. This one here is clearer than the other one. That is, we want to choose X in order to minimize the value of Y. And for that, we need to write Y as a function of X and then apply calculus to minimize this function. So this is the situation geometrically, and as we can see, we fold the sheet of paper and we found a right triangle here, which is the reflection following the line of length y of the right triangle with the dot lines. So these two right triangles are the same, this with the red lines and the other with this red line as its dot lines here. Because we have a right triangle here, of course, and that right triangle is just this one here. So the triangles are the same. We have this length we are going to call z. That is the length of this dot line here. The other dot line is x, and this diagonal red line is y. So we know that here we have the total length minus x, that is 8 minus x. If we draw a perpendicular line here from this point here to the other side of the sheet of paper, that is, we draw a vertical line, we have then another triangle here, and this, I'm going to call this distance from here to here, that is to this node, we're going to call it n, and these other two here from this node here to the edge of the paper, we are going to call it m. And from the figure, it's clear that m plus m is z. This is something that we can see clearly in this figure. Okay, so we want to write y in terms of x, and for that we are going to use these right triangles we have drawn here. We have the first one is this with the red lines. The other one is this here using the bottom right corner of the paper. And from the observation that this rectangle here up is the same as this rectangle with red lines, we can see that this side right here is of length x, because it's the same as this. When we fold the paper, this is just the same. And the other side is this one, that is, this is c here. Having done this, we now have all the right triangles. I'm going to draw them here. The first one is this inclined right triangle. And it's this one here. With the right triangle here, the right angle here, and x, z, and y. The other one, let's call this 1. Then we have the other is this here. So this is like this. This is the right angle, and we have 8 minus x. We have x here as a hypotenuse, and the other side is m. we're going to call it 2. And this one here is just like this, with the hypotenuse z. Here is the right angle, and here is, we have called it n, and we know that this side here is 8 because it's the width of the piece of paper. And we are going to call this 3. So we have now the 3 right triangles we're going to use and this statement here. So first we use this one from the right triangle 1, we have the first relationship is x squared plus z squared equal y squared. Remember, the hypotenuse of this triangle here is y. That is y. The equation is like this, the Pythagorean theorem. So we have this one. So I write the first one. The second thing we're going to write is this relationship here from this triangle. So from 2, uh, 8 minus x squared plus m squared equal x squared. And from the right triangle, this one here, the third one, we have, and so we have 8 squared plus n squared equals z squared. Okay, so we have this, and we call this equation here 2, and this equation here 3 in Roman notation. So this is our 3 equations from the 3 right triangles we constructed from the figure. And so we start with, and now we recall that we want to write y in terms of x, and from the first right triangle we have y here in terms of x and z, so we got to put z in terms of x, and we will be done. And we'll be done for the first part, of course. And then we have z, to put z in terms of x, we have this third equation. Z is written in terms of n, but we know m in terms of x from 2, and we know that n, m, and z are related by this expression. That's gonna give us what we want. So now we start with the second equation 2. So we get from this equation here that 8 squared minus 16x plus x squared equal plus m squared equals x squared. X squared is cancelled out, so we get from here that m squared plus 64 is equal to 16x. We have this equation here, and we can get a little bit further, we get that x is equal to m squared plus 64 over 16. Or, sorry, maybe it's not x that we want, sorry, it's m. So we get the other step we can do is m squared equals 16x minus 64, and then m can be written as the square root of 16x minus 64. We take a common factor 16 here, we get x minus 4, and so this is 4 square root of x minus 4. And in order to do this, we get to impose the condition that x minus 4 is positive or 0, so x minus 4 is greater than or equal to 0, that is x is at least 4. That's a very important condition. That is, we cannot do this less than 4. If we do this less than 4, we won't have a geometrically possible figure. Okay, so we have this partial result we're going to use after, and then we have written m in terms of x already, and this we're going to call 4. Okay, now we use the other equation here is 3. Now from 3 we get that 8 that 64 plus n squared equals z squared, but we know that n plus m equals z, and that is the observation we do right here following the construction. N tan plus m, it gives us all this whole length z here. So we can put n as z minus m and substitute that here. So, and then 64 plus z minus m squared is z squared. That is 64 plus z squared minus 2zm plus m squared equals z squared. Z squares cancel out, so we finally get 2zm equal 64 plus m squared, and that is why we are going to use this preliminary result here. M squared plus 64 is 16x, so we can, as we can see here, we have 64 m squared plus 64, so we can replace that with 16x. That means that 2zm is equal to 16x, and for that z is 16x over 2m, which is 8x over m, and we get to put m now we found here using 4. Z is equal to 8x over 4 square root of x minus 4, that is z is 8 over 4 is 2, so we get 2 in the numerator, 2x over square root of x minus 4, and that's it. So we have z in terms of x, and we are done to write y in terms of x. So this is equation 1. So from 1 and 5, that is this one here, we obtain that, let's see, x squared plus c squared, that is x squared plus 2x over square root of x minus 4 square equal z squared, y squared, sorry. And then y squared is x squared plus 4x squared over square root, sorry, over x minus 4. That is x squared common factor of 1 plus 4 over x minus 4. That is x squared times x minus 4 plus 4 over x minus 4. These 4 cancel here. And so we get x squared times x over x minus 4. And so y squared is equal to x cubed over x minus 4. Because all the lengths are positive, this we can take square root and get y equals square root of x cubed over x minus 4. And for that, x gotta be positive and greater than 4. In fact, greater than 4 would be the same as positive. And I put it right here. So this is our equation of y in terms of x. And the condition will be x greater than 4. And now for this to have sense, x cannot be 4. In fact, it must be greater strictly than 4. And from this, we get that it is positive and the square root of x cubed makes sense. So this is our equation. Now we gotta apply calculus here to find the minimum value of y and the corresponding x. So for that, we need the derivative. So the function we are going to use is the square root of x cubed over x minus 4. And we need to calculate the derivative of this function. Let's write it as x cubed over x minus 4 to the 1/2. And with that, here I'm going to write that we're going to minimize f of x is the goal. So the derivative is 1/2 times x cubed over x minus 4 to the 1/2 minus 1 times the derivative of x cubed over x minus 4 following the chain rule. So this is 1/2 times x cubed over x minus 4 to the negative 1/2 times the derivative is the quotient of two polynomials, so it's 3x squared times x minus 4 minus x cubed times 1 over x minus 4 squared. So this is 1/2 times. This can be written as 1 over the square root of x cubed over x minus 1. Then we can invert the fraction. So we get square root of x minus 4 over the square root of x cubed times, and here we have 3x cubed minus 12 x squared minus x cubed over x minus 4 squared. And so this is 1/2 times x minus 4 to the 1/2 times, this can be written as x square root of x because x cubed is x squared times x, and we separate the square root and we get this, times 2x cubed minus 12x squared over x minus 4 squared, and this is 1/2 times x minus 4 to the 1/2 over x times x to the 1/2 times 2x squared common factor of x minus 6 over x minus 4 squared. And here we can simplify things here. Okay, so we can say this is the 2 cancel out. This is x2. In fact, we can let it as 3/2. It's better to simplify with this x squared and this x minus 4 to the 1/2 with this 1. So we get in numerator x to the 2 minus 2/3 minus 3/2, sorry. That is 1x simplified with this x, and x over x to the 1/2 is x to the 1/2. So this is square root of x minus 6, and in the denominator we will have x minus 4 to the 3/2. That's our derivative, finally. And is 0 when x is 0 or x equals 6. It is not possible that x equals 0. Because x got to be greater than 4. Possible that x equals 0 because then x equals 6 is the only critical point. So the candidate to have for the function f to have a minimum. To know what kind of critical point this is, we get to find the second derivative. If we do that, we get that the second derivative of f at any x is equal to (12) over square root of x times x minus 4 to the 5th. And then the second derivative at the critical point 6 give us 12 over square root of 6 times 6 minus 4 to the 5th, which is a positive quantity. So for x equals c, f of x has a minimum value and that's what we're looking for. That is x equals 6, and for that y is a minimum in terms of x. And so if x equals 6, we can find y using this relationship here. So y is square root of x cubed over x minus 4. So the corresponding value, minimum value of f of y is square root of x cubed, 6 cubed over 6 minus 4, right here. That is 6 square root of 6 over 6 minus 4 is 2 square root of 2, and 6 is 3 times 2, so we get 6 square root of 3 times square root of 2 over square root of 2. And so 6 square root of 3, which is about 10 10.3923 inches. So this is the minimum value of y, and it is attained when x equals 6 inches.